join the class in between, right? So which is not preferred. So let's start discussing the today's topics. So like in the previous class, we have taken the overview of database design process, right? And in this, we have observed that the second phase or second step is the core step or the important step to model the requirements into some graphical representation of the given requirements, because in the traditional or in the most of the cases, the data requirements will be in the textual format. There may be a paragraph, there may be some points which will be given to you, and before going to implement or before going to create the database, you need to transform these textual requirements into some graphical notation, right? And that's why we are referring as a conceptual modeling of the data requirements, right? So this is, I think, one of the one of the very interesting part, or one of the very interesting, area where computer science students are working also, right? There are a lot many, in profiles in the industry available, which are based or which are dealing with this kind of work. They are simply converting the given inputs in text format, given inputs or text inputs collected, and they are simply mapping this input into some diagram, right? Because this uh, representation or visual diagrams are sometimes convenient to understand the requirement, right? So in the diagrams, you can simply capture a lot many things possible, and you can simply share this diagram or this representation to the person who is going to implement it, right? So basically, what is the need of, what is the purpose of conceptual data modeling, that you should be always careful, and you should see what is the importance of it. So because it gives, like in the case of data based design, it gives the first impression of data related requirements, right? So data related requirements are what? I mean, we have discussed it. So it is basically capturing all the possible requirements, function requirements of the system, which could be achieved by your entire product, entire software, right? So because a software will be delivering a lot of functionalities based on the data captured, right? So one of the example we have taken in the previous lecture about that sport event, right? So there are few requirements explicitly given. So you need to capture all those data through which you can achieve these functionalities on the software. That is the basic philosophy, right? Now from here, so the purpose of conceptual data modeling is to capture the impression of first impression of the data requirement. That is the basically purpose of it. Now this is something which we have already seen in the previous class, and this says at the stage of conceptual data design, where we are presenting the requirements in high level data model, and for that we will be using entity relationship diagram, ERD. So this is again a kind of diagram, right, which are being used for this purpose, right? There are various modeling diagrams available, and this ERD is one of it, right? So once this ERD is designed, now you can share the designed ERD diagram to a particular team who is actually creating the database, right? So the specific profile which is existing in the industry, in the IT companies, they are using this profile called database designer. So in some cases it is database designer who is designing these diagrams. In some cases it is the business analyst or maybe business consultant who is drawing all these diagrams primarily, right? So out of your class, maybe some of the students will be going to these organizations where they will get this profile, right? There they have to create the ear diagram for each and every requirement which is coming to a particular project or particular software, right? So that's why, I mean, we have naturally this course to pass in this your BTech engineering, but along with it, it will have uh, presence in your entire life. If you are joining a IT company, core IT company, you will have different days, different points where you will face this particular diagram, which is called year diagram, right? So from here, actually, that's what we have discussed in the previous class, where this diagram is required at which place and how it will be used by the further processes or further phases. So to understand that, we have taken this specific example of, or maybe scenario of a sport event where the data requirements are given to the person who is, I'm referring as a database designer. So these requirements are given to the database designer user, and it has mentioned that it will be designed, or this software and this database particularly is designed to keep track of these requirements, and this database should support the software to deliver all these requirements. So these all requirements should be delivered by the software where we are trying to create a database, for which we are trying to create a database, right? So software system is naturally the front end. It will deliver the functional requirement, but to deliver some requirements, it will depends on the data capture on the database. And that's why it is very critical and very sensitive task to design a database, right? Whatever attribute we will design, whatever constraint we will impose, uh, I mean, the whole functionality of software system depends on all these things eventually, right? So, I mean, in some cases, it is possible to design the database system directly. You do not need to perform conceptual design. But in the systems, or in the scenario where requirements are huge, there are many requirements to be designed in the database. In that case, it is recommended to perform this conceptual design phase, right? So broadly, if you see, the conceptual design phase will capture only three things primarily: the tables which needs to be captured, which needs to be designed in the database, attribute sets on each table, constraints which we have discussed, and the relationship among these tables or these attributes, right? So these are the primary things which needs to be captured, or which needs to be modeled in the diagram. And once you capture all these three, four things into a diagram, you can easily uh, share this capture diagram to the actual person who is going to create the database, right? And eventually in the future, we will be uploading the data, and based on this data values, you can achieve the desired operation of a certain software, right? So from here, let's understand what is year diagram, what are the different elements of a year diagram, and what is the different types, different categories of each, right? So broadly, you can see it is said as a ER diagram. So ER diagram means it is having two things: entities and relationship. Only two things are mentioned. So entities means anything which is existing in the real world, like it could be a person, it could be a passenger, it could be a student, course, faculty, name of the train, or it could be name of a country, something like that. Anything which is existing in the real world, and it could be acting as a noun, actually, right? So anything, if you read a requirement, if anything appears like a noun, like games, players, teams, uh, right? So these things can be said as an entity. So because it is important to capture the entity, like in the previous scenario which we are reading here, to design a database, the first thing is the entity which needs to be captured. Like we have captured what? We have captured teams, we have captured games, then we have captured players. And after this, sometimes you realize that some requirements may be achieved by simply capturing the relationship between the team. Not team, relationship between the entities, right? So that's why it is observed that by simply capturing entities and relationship between entities will be sufficient to design a database, right? So it is said in the conceptual data model, it is important to capture these two into a some visual diagram, so that the high level representation or high level understanding of the data requirement may be given to the database uh, creator, or maybe the maybe the any person who is going to create this database, right? And it is naturally will be shared by maybe by database designer or to database designer for the creation of the database logical data model which we are referring, right? So let's understand what is entity and what is the representation we can use for a particular entity, right? So rightly you can say here, entity is any real world object I'm sharing as a, maybe it could be a person, uh, right? It could be a passenger, it could be a student, it could be a team, it could be a player, it could be a country, anything, right? It could be anything, anything which could be acting as a, I mean, it can be event also, it could be sometimes transaction also, right? So I mean, in this world you can have n number of real world objects, and whenever we read a requirement, you can identify these entities carefully. I mean, you can also read a requirement and it can be a very simple task to identify the entity, right? So broadly, if you read, uh, after reading these entities, you can easily categorize them. Like for the, if you want to design a banking system, a system which to support the banking operation, customer is the one entity. Then there could be an entity called bank branch, right? So similarly, you can identify lot many entities for a certain business area. Like for the institute, like for our college, if you want to design a college management system and its database, you could possibly create students, faculty, course, companies, hostels, library. Within library you can create books also, right? So departments, so likewise you can create or identify these possible entities for it. So if you see or identify all possible entities and certain application area or maybe business area, these entities could be possibly of two types. First type is called strong entity, right? Strong entity. So I refer strong entities to the entities or to the objects which can define themselves, right? It which can define themselves. Maybe you can say, uh, to define the identity of an object, you do not depend on any other. Like course, to define a course, you does not need any other declaration or dependency, right? Faculty, student. So your existence in the college does not depend on anyone, right? Your existence basically within an institute, within a specific area, business area, does not require inputs or dependency from any other one, right? Like for the customers in a banking system, does not require definition or declaration from any other entity. So all those kind of entities could be called as a strong entity, right? And there are some entity for which you can say, uh, the existence of this entity depends, particular in this particular business area, depends on the other entities, other strong entity rather, right? So if you see, like in the case of institute or maybe college, uh, the existence of, if I declare scholarship as an entity within a college database, if I declare scholarship as an entity, it will be a weak entity, because the first case, because each and every student does not get a scholarship, right? And existence of scholarship depends on the existence of a student, right? So there are two preconditions you can see. So if you are observing an entity as a weak entity, you can see whether the existence of that entity depends on the existence of other. That's one thing. Second, you can see whether the data in this entity is applicable for each and every other dependent entity or not. Like for the scholarship case, you can see the existence of scholarship entity depends on a student, right? And each and every student is not getting a scholarship, something like that. So it is kind of a partial applicable or partially related, right? So all these kind of entities could be defined as a weak entity. In case of banking system, if you want to design a banking system database, there we can have a loan as an entity, but because each and every customer is not applying for the loan, so loan could be a weak entity, right? So for any database, or you can say for all databases scenarios, there must be some entities which could be assumed as a weak entity, right? Like for industry, maybe in the industries or in organizations, sometimes people are often declaring their dependents, right? But in that case, so dependents are declared for the, it is declared for the some kind of benefits, but in some cases it is not applicable for few employees, right? So this dependent may be considered as a weak entity, right? So it is again depends on the person who is designing the database, their experience, their idea about the possible requirement scenario. So between these two entities, strong and weak entity, whenever we are going to represent it in a diagram, in the entire diagram of ER diagram, we will be using these two notations to indicate the strong entity. We will use a simple rectangle box, right? And within rectangle box, we will be simply mentioning or adding the name of the entity, right, within box. And for indicating or representing the weak entity, we will use uh, doubled, you can say a doubled rectangle box, something like that. So these two representations are used to basically indicate that certain entity is a weak or certain entity is strong, right? That's the basic simplification and basic representation we will be using. So after this, the next important thing is that what are the different attributes we are assuming for a entity, right? Because each and every entity which we have identified must have attributes, right? Because without attributes you cannot identify an entity. Like for a student, it should have a name, it should have a roll number, it should have a date of birth. So without any attribute, you cannot identify entity, you cannot establish an entity. So each and every entity, it should have at least one attribute, right? That is the basic need for the diagrams of the entity, right? So let's see what are the kind of attributes we can attach to an entity. So you can read here. So attributes are what? It is a property, features of a real world object, which we are referring as an entity. So whenever we see that attributes for an entity, there are some attributes where only one value is possible. Like for your, like for a student, this date of birth is a value where we have only one value. Date of birth, first name and last name. Address could be two. I mean, but I cannot say that. For some student, we are having two addresses. For some, it is one. So all those attributes where only one value is available, one value is applicable for a entity object, are referred as a single value attribute. So the values are atomic values, right? And the second type of attributes could be possible where multiple values are available. Like for a student, you could have two addresses, two mobile numbers, two email IDs, something like that, right? So this is possible. Like for some student, so one student may work in two different projects. Similarly, one student, one employee can work on two different projects, something like that, right? So in some cases, in some entities, it is possible to have attribute which will have multiple values on a single database instance or single database object, right? There are some attributes where we can derive the value or where we can generate or estimate the value on the real time basis. Based on the date of birth, you can generate the age value. So this is something deriving the value based on the base attribute, right? So now, based on these three classification, you can say how to represent them in a diagram. So whenever we found attribute as a single value, we can simply use this particular shape. And whenever we say attribute is a multi-valued, we can have this representation. You can see, I hope, right? And if you have to represent a diagram, a particular attribute as a derived attribute, you can use dashed object, right? So these are the three possible uh, types of attribute on an entity to an entity. And whenever we are going to represent an entity, and with this entity, if you want to indicate the nature of the type of attribute, you need to use these notations, right? So this is about the second concept, which is attribute. Now we are going to the important aspect, which is called relationship. So naturally, we will have more than one entities on a business scenario, on a requirement. So it is important to model the relationship between these two entities. Like if I assume you're trying to design a college management system, there must be some relationship between student and course, student and department, faculty and department, student to the scholarship, student to the hostel, something like that, right? So if we are assuming we have a student entity, here we have course entity, then relationship will be of some ratio, right? Ratio or maybe some relationship. So like in the case of student and course, if we have two entities, student and course, the relationship P of type 1 is to M, because one student will be enrolling for at least 5 courses. It is one of 1 is to M type, right? Similarly, if a student is trying to work upon a certain project, so like in our case, in our institute, the project and student mapping is 1 is to 1. One student may work upon a single project. That's what the relationship, right? And if you capture the scholarship, it could be of 1 is to M type also. One student may get 2 scholarships, right? Faculty, student with department will be 1 is to 1 type. One student may enroll in one department, right? So whenever we have captured all these entities with their attributes, you need to define the participation of each entity objects in the relationship, right? So broadly, this concept is somehow coming from the mathematic course or mathematical conception. So you might have some familiarity with it. So now let's understand how this can be drawn, how this can be reflected by using 4 different examples for 4 different scenarios. So you can see, you can use this diamond box shape to represent the relationship, right? So like in the very first instance, if you see example of 1 is to 1 relationship. So here, what is designed in the left side in this diagram, first diagram, employee entity is mentioned, and within this, different objects of this entity is shown. So like E1 is indicating the first employee, E2 is for second employee, E3 is for third employee. So it has listed all the possible employees within the entity. On the rightmost side, in the department D1, D2, D3. So this indicates different departments in the department entity. Now, if I wanted to understand, if I wanted to map that which employee is managing which department, maybe it's like which department is heading which department, which employee heading which department. So if I draw the relationship, you can see only one employee can manage one department, or one employee can you know uh, control one department, something like that. So you can see out of these maybe 120 employees, only 3 employees are having 1 is to 1 relationship with the departments, right? So this is a typical instance diagram. This is a relationship instance diagram. So in between, you can see this manage is written. So manage is the name of relationship, and the type is 1 is to 1. So when you draw a relationship between entities, the first thing is you should mention the ratio, right? Ratio of participation in that relationship. So if we have observed, there is a relationship between employee and department, and its ratio is 1 is to 1. That's simplistic way. But you can carefully observe, out of these 120 employees, few are participating in this relationship, and few are, I mean, free. They are not participating, or they cannot participate in this relationship. So you can carefully observe from the department side, because if we have 6 departments, each and every department object will be participating. So from department side, it is total participation, because each and every object of department entity is participating in this relationship. But from employee side, because it is not possible, right? So for from employee side, it is partial participation. So again, it is a property of relationship, right? So this also you need to see whenever we observe the relationship. Now let's see the second instance in the rightmost diagram, where we are having employee as a first entity. In the second, we have department, and then we have works for as a relationship, right here. So you can see in the employee we have these employee listed, in the department we have listed departments. So now we are observing a relationship between employee and department, and the relationship name is works for. It means which employee is working in which department. So now you can see from the employee side, each and every employee is attached or participating in this relationship. And if you see the department side entity in its object, in each department more than one employees are working, right? So it is kind of one is to many relationship, right? One is to many, like from employee side it is one, because each employee is working on one department, right? So each object of employee may have one participation, right? One participation. But if you see in the department side, each object of department, like D1 is having three association. So this side it is M, right? So this is again an instance of 1 is to M relationship. Similarly, if you read the third possible type, which is called M is to N relationship. So here you can see if it is allowed that one single employee may work in more than one project. A single employee can work in more than one project. It will become M is to N relationship. That's one other instance. So you can identify any object or any scenario where you can easily understand this relationship situation, right? So in both cases, like here in the first instance where employee is managing department, second where employee is working on a particular department, and in the fourth where we are assuming that employee is working on a project. In these three cases, we are having two different entities in a relationship, right? Two different entities in a relationship, and we are mapping their relationship, their participation. But there is a possibility that uh, we could have same relationship in both sides. It's like if I wanted to draw a relationship that uh, out of within the student class, within the student of 120 strength, who is the monitor of each section, right? Like for your class we have 6 sections. So if I wanted to draw the relationship between student and their monitor, so in both side I have to place the student, both side I have to place the same entity, student and student. Out of one side student, I have to make the relationship as a monitor or maybe the class representative. So there are various possibilities where we are using same entity in both sides, and this situation is called recursive relationship, because both side it is the same entity who is participating. So this again is drawn as a recursive relationship. In this case, in both side employee is placed, and the relationship is called supervision. So like in the many offices, it is observed that employee is supervising some other employee, employee is managing some other employee. So in the organization we have this entire set of employee, maybe 5,000, maybe 20,000, but out of these 20,000 or 5,000 employees, some are working as a manager for others, some are working as a supervisor for others. So in both sides it will be the employee entity which will be used, right? So these kind of instances are called as a recursive relationship, right? So these are the basic notations, basic concepts which I wanted to share. And if you need, we can basically revise it. So primarily the entity relationship diagram has three aspects, three things to be captured, three things to be identified. First thing is the entity, which is the real world object existing or identifying the requirements. And within this, we could have two types, strong and weak. For strong entity, we have one representation. for weak entity we have different notations with double dash is rectangle box. And the second aspect is attribute, which is applicable for each entity. And if you want to identify the attributes for entity, it could be of three types: single value attributes, multi-value, and derived attributes. To represent these three different types of attribute, you can use different notations. And the last and the least part is the relationship between the entities, that also you have to draw, right? So whenever we have these kind of situation given, whenever we have given these kind of requirements form, we have to identify first of all entities, which we have done in the previous class. Entities could be teams, games, and players. So after identifying the entities, you can identify the weak and the strong entities. Then you can identify the possible attributes for each entity. Within that, you can identify single value, multi-value, and derive. And the last part, as a last task, you need to draw the relationship. You need to assign the name of the relationship and its ratio, right? So these are the three prime things you need to basically you need to draw, you need to arrange, right? So for instance, let me take a specific, you can say, examples through which you can understand that what a particular ear diagram looks like, right? So let me look into the Google, and let me showcase a specific instance of uh, you can say the ear diagram, right? So I am sharing you some of the instances so that you can have a better idea. So yeah, yes. So I think it is visible to you now. You can see there. So if you search within the Google image, you can get lot many diagrams like this, right? So you can open any diagram and see what are the different internals it is showing. So you can see here there are n number of diagrams available to have us, and these different diagrams are for different scenario, right? So like typically you can see, so you can see if you open this, you can see it is about, and a department is entity, employees entity, dependent is entity, project is entity. And you can see there is this rectangle box shown which which demonstrates the relationship. So it can be read as department controls project. So this is how you can read also. So you can read, you can understand that this relationship demonstrates this requirement, which is written in the uh, data requirement set. Simply you can read department, maybe employee works for department, employee manages the department. So if you read the relationship, you can make a sentence also out of it, right? And for each, now you can see dependent is a weak entity. You can see there is a double rectangle box which is shown. And if there is a relationship between weak entity and strong entity, that relationship is also, you can see the diamond box, which is a relationship indication relationship box. It is also shown in a double diamond box. It means this is coming from a weak entity, right? So this is very important. Now you should be at least looking at some of the similar kind of diagrams so that you can have an idea how to draw it, what is the purpose of it. So the basic needs we have discussed, that for what purpose, which indicator or which shape is used, and how these shapes can be arranged for different purpose, right? So likewise, you can explore in the internet for getting an idea that how could you design a specific ear diagram, right? So that is it for today's discussion. And now, from now, I will be sharing a few scenarios to experiment with, right? In this ER diagram, drawing concept or understanding these concept. So